But you can take it from the chat right now.
And just a short question before we begin. Next week, when do we have midterm, on Tuesday or on Thursday or on Friday?
So I think it will be our general exercise session, so it will be Friday.
Okay, and it will take 1 hour 20 minutes or more.
Oh, let me check. Let's see how it was last year. It was 80 minutes, so yeah, it will be one lesson. Have any other questions before we start? You already tried to write summary?
In the process of exploring the article.
Nick, and which one you choose from which year?
Second. It's year 2021. The author is Son.
Son?
Yes, like
Market power into silent markets?
No, estimating platform.
Yeah, market power.
Yes, it is.
Was it good?
It's really interesting to see how the concepts we discuss in classes, how they are applied in some real research. And it's much more complicated than we discussed, of course, but still.
Yeah, we discussed just the basic stuff. But generally, what is your plans? I mean, all of you, after the bachelor program, do you want to go to master or search for a job?
Personally, I plan to go for the master degree.
I have the same.
Okay. So I think we can start.
Sorry. And about this article, just a brief question. So when we are talking about merging of platforms, do I understand it correctly that it's the process when two platforms unite into one?
Kind of, yeah.
Yeah, okay. Thank you.
It's actually, that's not my topic. I'm doing behavioral economics and most micro theory. So the two-sided markets, it's connected to micro theory, but not really my topic. So that's it's not always works like you can teach whatever you are doing. So I'm not the best guy in the world who knows everything. Yeah, I know better than you. Yeah, but be that someone else. Oh, yeah, for sure, the guys who written this article, they knows better. Okay, then, yeah, I think, so we have only 4 of you today. Then I can actually suggest you 2 ways. We can go together through the problems, as we did during the first exercise session. So, like, I will go through step by step explaining you stuff. But this kind of similar to the lectures. Or we can just discuss the questions which is about to talk or write down something, and then you will derive formulas by yourself. And if you have problems, you can ask me after 5 minutes, for example. So you kind of can try yourself before midterm, because it will be kind of similar.
Like we are discussing, I know, for example, the conditions of the task. After that, we'll have like several minutes to try to do like the first task, and after that, we do it together, right? That's the second variant.
Yes, like maybe 10 minutes, but we will do together the first, I guess, which one? 3 questions. So they are mostly about talking. Okay, let's firstly discuss that. Have you already downloaded the task? You can find it in the chat.
Yes.
Like all of you, because I will stop sharing the task, and yeah, because I will use the whiteboard. So then, okay. And yeah. Okay, now you can see me there. Yes, no?
Yes, we can.
Yes.
Okay. Yeah, I can see myself as well. So we have 2 platforms as in our model. So that's denoted by I, 1 or 2. Or as well, we have two sites. Yeah, for example, jobs and candidates. And we will use a seller or buyer. What else? So they have subscription fee. Yes, so for platform. So there is no difference for different site, but yeah, so each platform suggests to pay subscription fee for both sides the same. So then the one who joins the market randomly matched with a member of another group, so which means that not numbers matter of another side, but the quality, average quality, right, as on the lecture. Yeah, then we can say something about the types, so that we have sellers and buyers, and they have type theta, and it's uniformly distributed on AB. Yeah, it's different, the B, right? So here it's buyers, and here it's parameter. So they know that, yeah, they have something positive. Yes, so then what is the surplus of joining the platform for buyer and seller? it's multiplication of B plus a minus type of, for example, buyer, and then we multiply by a minus type of seller. So that's what we earn the match and gain if it happens. Yes, and then we have rational expectations. So then we expect whatever happens on the other side, it happens according to the equilibrium.
Excuse me. About surplus from match. So in this task, we're not given any kind of utility as we were before, right?
But you should write it.
Okay, and about surplus. So how to think about it? It's like what the society gains from one match. Well, successful match.
No, that's what was what gain exactly the pair of buyer and seller who matched.
So without network effects.
Yes.
Okay.
So then, yeah, I think it should be specified how the surplus divided then between seller and buyer, but let's assume that they divided. Yeah, we can assume that they receive the same surplus for each other. So like that's this is what gain each of the members of pair. Or we can divide it by half as you want.
Well,
what you can find logically.
So it's up to us. Doesn't it influence the solution?
Yeah, it is. But it's not specified in the problem. So probably I have to.
In this case, it's logical to assume that they just divided like 1/2 for each.
Yeah, then the utility of agent J joining the market will be what?
And sorry, before moving forward, why surplus looks like that?
So that's kind of you define your utility function.
So this surplus is just given to us, or we can like okay.
So we can think then about the utility function. Yeah, it's not part of the task yet. So then let's do it right now. So can someone help me to write down the utility? Which cases the agent have?
Like this multiplication divided by 2 if match is successful and 0 otherwise, or something more complex?
So then, firstly, if agent join some of the platform, right? Because we have 2 platforms now. So then, so the agent normally have 3 options, right? Not to join the platforms, join one platform and another one.
But we can write joining or first or the second platform like in one row.
Yeah. And so it'll be 1/2 b plus a minus our type b plus a minus, what should I write here?
Theta minus j.
Not really. So then imagine join the platform, or thinking about joining the platform, so they don't know about the decision of other types.
Like theta minus j expected.
Right, so they need to write the expectation of theta minus j conditional on who joins platform, let's say I. We are talking about platform I. Then what we should add to the utility? Yeah, let me actually rewrite it a bit, since it's a bit to the left, just to have a space. So the utility of j is, so as 1/2 platform I. Then what we do, we need something else in the
Yes.
utility?
Of course, it's like minus capital M j. No, I. Yes.
Yes. So then if we join platform I and 0 otherwise, so that's our utility. So then let's come back to our setup. So then what is the timing? Timing is that firstly platform 1 chooses M1, then platform 2 chooses M2, and then platform cleans choose to join or not to join the platforms, and each one to join. Yeah, I don't have behind you.
Sorry, what?
Yeah, can you see the task? Yeah. Some there.
We can.
Okay. So then let's start from the first question, or maybe someone has any questions about the utility?
So about the utility, it's like the surplus minus the price, like for joining, but we should assume that agent doesn't know the type of other agents, so it's not like you know.
Yeah.
Okay, and
So
that's why we use expected value. Okay.
So we did the same for one-side platform and during the lectures as well. So then, yeah, first task we actually did, right? We need just to write the utility function, what we already did, and profit function of a platform. So then, if we will denote this as a first task, what is the profit function of the platform I?
We don't have any transactional price, right?
Right.
So it should be just capital MI multiplied by N.
What is N? Oh, okay, N. But what is N?
N buyers of I.
Yes, so number of buyers on platform I. Then that's it, or something else?
We assume that connection cost is 0 or not?
Yes, let's say that we don't have it. So we can generally write it, but
And the same thing for sellers, right?
right. So there will be an sellers on platform I seems, and then generally we can write that that's supposed to be. So let me. So that's MI minus C of connection, if you have it. Or it could be different for different platforms, or then it's going to be different for different sites as well. So it's the costs for buyers and sellers can be different in general. So then let's move to the second question. So if everything clear for the rest, guys, Joseph, Tatiana, Vladislav.
Yes.
Yes.
Okay. Nice. So then the second question is, which condition we need to impose on M1 to guarantee full participation of clients at platform at equilibrium? So what's supposed to be M1 such that in equilibrium everyone will join any platform?
Like the utility should be greater than 0 for every day.
Yes. So it kind of doesn't matter whatever the second platform do. We want to guarantee that everyone joins from the first step. So then which agent has the lowest utility of joining the first platform?
The one with high theta.
Yes, and what is the highest theta?
B.
Yes, so plug in here the theta equals to B. Yep, so probably in both cases. Right, because maybe we can assume that the second platform will match everyone except the last guy. So then we can say that the utility of joining the platform with having B and then being matched with someone who has type B minus M1 will be greater or equal than 0. Right? Well, here is a plus. Yeah. So then we have a squared over 2 greater or equal than M1. Right. And that's the condition.
Why the expected value is equal to B as well?
So because we don't know how the second platform will behave, and let's say they do it like they want to take those clients who has higher theta, and then they just extract from platform 1 everyone who is higher than the lowest type. So such that just the lowest agents will join the first platform. So then we guarantee that these types joins the platform 1.
Like, we are not trying to predict what the second platform does, just say that we need B in this case, or what?
Yeah, we are not talking by now about the second platform. It will be in the next tasks and in the next points. Yeah, so that we don't. Then we impose the M1. We just don't think about whatever do the second platform right now, and they don't talk about that they respond in equilibrium. How?
Okay, so it's just the simplification, I guess.
Yeah, that's just question about simple. Yeah, there are dependence in the equilibrium for sure. But since we need to solve it later, we will see how it goes. So that's the simplest condition you can think, simple sufficient condition which you can think about from behind. So then let's think that a second platform entering the market now, which is the first point or third point. And wants to overtake, so just attract some clients from first platform. And is it correct that platform 2 can't achieve this doing the price lower? So the second platform joins the market and want to attract some types. Is it possible that M2 lower than M1?
Shouldn't we do just the similar task as we did on lecture? Like, just let's assume that M2 is less than M1, and let's try to solve it. If we can solve it, then it could be so. If we can't, well.
Yeah, actually the last task is about to solve the problem soon. This one is about to think if it can happen or not from just discussion. Yeah, we will solve the problem a bit later. But generally, can you think such that the price which is lower will be works such that the platform will take some clients from platform 2?
Given the certain degree of the diversification in users type, yes.
So then let's think. Let's consider the agents, right? So they are from A to B, right? And so let's say that we have the price for platform 1 is. So what happens if price for platform 1 is low? Can they do it even lower to extract some agents? So probably from the lecture you remember that the price is supposed to be a bit different. So let's say that we have M2, M1 is given, right? So some there. And they have the indifferent guy who joined in the market and not joined in the market. That will be with theta. So theta lives on this interval. The platform is symmetric, right? So that both sides are similar. Then we can find the indifferent theta. And who joins the platform 1 and who not?
To the right, they don't join, and to the left, they join.
So yeah, so this join. So this means that for this type, he's indifferent. So his utility from joining the market is kind of 0. So he has 0 from joining the market and has 0 from not joining the market. So that means that those who to the right expect negative utility with given price M1. So then let's say we take the the second price lower than so that the second platform joins the market and want to take some clients from platform one and set the lower price. So what does it mean that lower price is implemented for platform 2? So let me denote this. Indifferent theta for platform 1. There will be the indifferent theta for platform 2.
It should be to the right. So from those who decided not to join, maybe some part could join the platform with the lower price.
Yes, so that's here will be the indifferent person who joined the platform 2 probably, but his utility depend on the types on the platform platform 2. Yes, because for this person first, his expected utility is his type multiplied by the average one, which is in between, and theta 1 bar. And then yeah, so that's minus phi. Well, now the second platform joined the market and introduced the lower price. So such that they're supposed to be the one who is indifferent between joining the market.
Do I understand it correctly that the question is whether these theta 2 expected will be less than the right board of will be less than theta 1 or greater?
Not really expected, but the one who is indifferent between joining the platform 2 and platform 1 right now. So the main idea is that joining the platform, the guy who is right now indifferent, right? So this teacher, right? So he will know that the indifferent guy, so like we don't know there will be the theta expected from joining the platform 2, but it will be for sure lower than so worse because it's closer to B, so it will be somewhere to the right. Right, it can be here, but we don't know yet. But we can say that this theta for second platform will be lower. And then the guy who was indifferent to join or not to join the platform 1 will still prefer to join the platform 1 because platform 1 has higher expected match from the other side.
Could you please illustrate your last idea on this graph?
Okay, so then there will be the guy who is indifferent between joining two platforms, but his utility depends on the expected theta on other side. Yeah, this the green one. Yeah, and probably this will be the guy who. So the average guy will be more to the right compared to the, so we compare these two. Who is average on the first platform and who is average on the second platform. Yes, a second and second one is will be closer to B, right? Because now the price is lower. And can you write down the condition such that yes, the guy who joined the platform 1 now will prefer to join the platform 2. Yeah, that's a bit complicated.
So, for example, well, I still don't understand. Does it matter where these expected type of joined the second platform? So theta second expected. Is it like less than theta 1 with Domik? Or is it bigger? So do we care about it or not? Or we only care about the expected values?
So we cares about the expected. So it doesn't matter actually, because what is matter is the utility, right? So what is matter is so there now we can assume that if there are two platforms, so before these guys was indifferent between joining the platform and 0, right? But then the question is, so would it be possible such that this guy who was theta 1, and if he's not joining the first platform, he receives 0. So he's indifferent between joining the first platform, which is matched with average base, right? So this gives him 0 utility. Then we know that now there are the second platform. So before this guy, theta hat 1, this one, you receive 0 utility anyway. And now there are second platform with lower price, right? So, and probably, yeah, the question is, okay, I used Greenman, so that the second platform can do, yeah, here will be the indifferent. Can it be such that there will be these guys who join now the second platform, such that the indifferent between first and second platform, you know, right? So this one is indifferent between joining first platform and second. So what we know now that the average will be low for the second platform. So before the border guy got his theta 1 indifferent, yeah, B plus A minus theta 1 indifferent multiplied by B plus A minus this theta 1 expected. That was his utility minus M1. And what was the value of this utility since he was indifferent?
It was equal to 0.
Right. So he was indifferent to join the market or not to join the market. And now his utility, if we have the have joined the second platform join. So his utility is his type as well. But then he is supposed to be so what do we know? We know that price is lower now. So that this price for second platform is lower. And then we have theta average. And theta average is lower as well. No. So theta green is higher because it's A and B. Right, so and A is lower than B.
This theta, you just wrote the same theta. Maybe it's theta 2?
Oh, yeah. I'm more focused on colors, so. Right, and the question is it possible?
It's possible, but not necessary.
Can we show it somehow?
Well, we have like again, like on one of our first lessons, like two forces which move in opposite directions. So to compare those utilities, well, there could be like variance. So it's possible, but not guaranteed.
Yeah. Okay. So but from the last lecture we show as well, so that it's going to be symmetric. If first platform choose too high a price, such that no one with lower types. Well, like this platform could exist. The question is, can it be such that the lower type will join the platform with lower price? Okay. The question is, what is the difference between average theta and end price? So then, yeah, that's just general thoughts and general question. Then let's move to the fourth question.
So, in the end, is it possible or not?
So I think it's possible depending on the price, right, and costs. So the answer, if we can put such a price that it will be, so if price of the platform 1 is high enough, such that we can make this difference, because price cannot be lower than 0, right? Even they have like some zero costs of joining the market, so that it's zero connection costs for platform. Well, you can see that you have to have some difference between prices to substitute this difference in average theta. And then what's going on if you attract more, so that if you indeed attract these agents to join the platform 1 or platform 2, sorry, then you will move your average theta bar to the left, right?
But it will happen after like the process of I don't know, users migration from one platform to another.
Yeah, but then the agent decide to join which platform, they calculate expectations. So probably the indifferent guy will be, yeah, so then we can calculate the indifferent guy such that, because the expectations then depend on each other.
So it really depends on prices in this case.
Yeah, how the first platform impose the price.
Okay.
So then, fourth question is now to calculate something. Indeed. So then let's say that now we said that the price for second platform is high, and so the second platform will serve the agents with higher quality. Yes, so and then let's assume that the population is divided between sellers and buyers who join the platform 1 and platform 2. And then there is a different type. So can you write the theta1, the theta head who is indifferent as a function of M1 and M2? So let me give you 5 minutes to this, and then I will write you the answer so you can compare. Okay?
Okay.
So, but yeah, I will ask everyone to do this, not only Nick, because you probably need some training for midterm, and that's in your interests. Okay. So however everyone received their answer?
I'm still struggling with an indifferent agent, actually.
So okay, then let's do it together. So you have the agents. So from A to B.
And about agents, do I understand it correctly that now and during the lecture we have like the the same theta, well, I mean theta с крышечкой, for both buyers and sellers because of the symmetry of the distribution of the types. So, for example, if I don't know, types of sellers were distributed like uniformly from A to 2B, not 1B, it would not be the symmetric task,
Yes.
right?
Right. So what is written here in the task? So that you have price for second platform is lower than price for first one. So, and as a result, the population of sellers and buyers gets divided between platform 1 and platform 2 with theta hat as the indifferent type. So that we have the indifferent type here. And they have those who join the platform 1 and those who join the platform 2. Since they are divided between platform 1 and platform 2. Generally, it can be more complicated case than we have not all the population divided between two platforms, right? It could be generally that someone doesn't join at all, right? And we have to think about another indifferent agent who is not joining at all. But yeah, we have set up that the population is divided between platform 1 and platform 2. So then we're thinking about that everyone from theta hat and below is joined to platform 1. And everyone else joined the platform 2. So then what is the expected value of the agents on platform 1?
It's theta plus 8 divided by 2.
Yeah. And what about the second platform?
Theta plus b divided by 2.
Yes. So, and what we need to compare for indifferent agent?
We need to make sure that the utility from joining the first platform is equal to the utility from joining the second one.
So what is the utility of joining the first one?
Do I understand it correctly that it's like 1/2 of b plus a minus theta multiplied by b plus a minus this expected value?
Yes.
Okay.
Sure. So it will be 4. But then what you need to do? You need to pay the fee, right? So for first platform, it's okay. So now we have opposite case, right? The price for for second platform is higher, and the best types are served by the second. Sorry, I will change it a bit. So that's the second platform, and that's the first.
And logic behind this?
So it's written in the task actually. So that
Yeah, I see. About so we assume that well, we know that our utility depends negatively of theta. So
yes.
so what?
So the higher theta has the possibility to pay less. So then they will pay less for lower price and then achieve the worse match. But those who has higher theta, they expect more gains from the platform, so they would like to join the platform with higher quality.
Okay.
So then we need subscribe M2 for the best types, and this is supposed to be equal the utility of joining the platform that's we have the same type, but then we have different average. And different price. So what we need to find is a theta hat as a function of M1 and M2. Right. Is it? Yes, sir. Then we have B plus A minus theta. And we have B plus A minus theta plus A over 2. So that's from the first row. And then with minus will be minus B plus A minus theta hat plus B over 2. Right, and this equal to M2 minus M1. So any questions from someone? Is it clear for everyone?
Give me just half a minute to analyze.
Okay. Because if you're not sure, just ask. We will discuss details.
And can you scroll a little bit higher? Mm-hmm. Yes, thank you.
So what?
Yeah. Sorry, I just wanted to like repeat the logic of our decision, like who joins which platform to the left and to the right of theta estimated. So at first we need to see like utility depends positively or negatively on theta.
Right.
And after that, well, in our case, it depends negatively. In this case, those who have higher theta, they can pay less, so they will join like the cheaper platform, right? So the platform with the cheaper price of entering.
Yeah.
Okay. Well,
because
subscription fee. Yeah.
So the higher theta means lower quality. The lower theta means higher quality. It's
In
from
this
the
case.
utility.
Yes.
Yes, and then in the task it's written that platform 2 serve the higher quality, which means lower theta. That's but yeah, the logic is following that since you gain more surplus, you would like to pay more to be sure that you will be matched with the guy with higher quality as well.
Yes, okay.
So then any questions by now from the others?
Everything is clear.
Okay, we just left with Joseph and Tatiana. Okay. So then, yeah, let's open brackets. So then here will be minus theta over half, right? And here will be plus theta over half, so there will be no quadratic equations by now. So what will be left? B plus A minus T theta hat. And there will be B plus A minus B plus A. There will be minus A over 2. And then it will be plus B over 2. And this equal to 2m2 minus m1. So and then we have the result, right? So what we have, B plus A minus theta hat equals to 4m2 minus m1 over B minus A. Am I right? Yeah. So then theta is B plus A minus 4m2 minus m1 over B minus A. And what we can say about how the theta depends on m1 and m2?
Negatively on M2 and positively on M1.
Yes, so coming back to our graph, so if we ask higher price for platform 2, then theta becomes lower, and lower means moving to the left. Yes, and if M2 increase. If M1 increase, yes, if M1 increase, then we will have the opposite effect. Right, so if M1 will be the same as M2, closer, then beta will increase. Yeah, but then we supposed to be sure that yeah, from the task we learned that yeah, everyone is divided between platform 1 and platform 2. What we by now leave aside that the surplus is supposed to be positive, right? That we still have the outside option not to join the platform, so that the indifferent guy would like to join the platform at all. Well, let's move to part 5. So that in this case, what is the utility maximization problem? So Do you want to finish the task firstly, and then have a break, or do you want to have a break right now, and then we will continue?
Maybe finish it first.
What about Tatiana and Joseph? Are you fine with that?
With Nikolai.
Yeah.
Okay. So then, what is the profit maximization problem for platform 2? So you remember they write the profit on the top.
So it should be M capital 2 multiplied by the sum of N, like N buyers 2 and sellers 2.
Yes, and what we can say about buyers and sellers?
We have a symmetric solution for them, so their number should be like similar, the same.
Yes, so it will be M2 multiplied by 2, but who joins the platform from one side? So we know indifferent theta, right? Coming back to our graph. So who joins the platform? What is the number?
Theta minus A. No.
But I can't hear you, sorry.
Theta minus A.
And divided by 1 probably if we have total mass of 1, but yeah, theta minus A. Yeah. So then this is theta. And then we can rewrite it as a 2m2, and then theta as here, right? B plus A, then there will be minus A, so we can not write A, so it will be B plus, so minus, it was 4m2 minus m1 over B minus A. So they need to maximize this profit with respect to M2. So let me give you how many minutes you want to derive the first order condition and find.
Several minutes, like 3, 4.
Okay, that give me 5. So let me give you 5. Time starts. Okay, have you got the results?
Yes.
You shouldn't be silent in that case.
So I've got the result for M2. I've got B multiplied by B minus A divided by A, 8, plus M1 divided by 2.
I have the same one.
This?
Yes.
Yes,
Okay.
and I should have got the same one if I didn't lose the minus.
Let me briefly solve it. And then
But actually, I have a minus before M1 divided by 2. Is that the minus that you have, Nick? Or no? It may be my mistake.
Yes, it is, but it shouldn't be there. If we see like
okay.
the function is like minus on minus.
so then it's 2b minus a plus. Right. So then we have. Okay, I don't need 2 here. So then M2 is, yeah. So what I can see that M2 is increasing in M1. Great, you were correct. And then the last question for this task is, so now they need to plug the M2 into theta hat. So what was the theta hat? So that was, yeah, B plus A minus 4, M2 minus M1 over B minus A. So then we need to put it inside. And answer the question, what is the distribution of theta we can support the equilibrium. So you remember from the lecture that we have some condition on A and B. So probably here they'll be the same. But what you need to solve for this? So what we need to solve to solve the rest of the problem, what we haven't done yet.
We have to solve the theta estimated with a star, like which depends only on our parameters A and B.
Yes.
And after that, demand that it should be less than B and greater than A. Otherwise, we don't have two platforms.
Sure. And what we need to solve for that?
To find theta with a star, or
Yes, so which problem I should write down?
we should maximize we should maximize the profit of the first platform. shouldn't we?
Yes. Yes, by now we solved the profit maximization problem of platform 2, depending on price of the platform 1. So now we know how the platform 2 will respond to price of the first platform and how the population will be divided between two platforms. So we can solve the profit maximization problem of platform 1, right? So what is the profit of platform 1 as a function of M1 by now? So you remember that this is M1 multiplied by number of sellers on platform 1 plus number of buyers on platform 1. So M1 is here. Then we know it will be 2 times the same. And what is here?
It should be B minus theta estimated divided by 1.
No? B minus theta, yeah.
And
Not estimated, but had. Actually, that wasn't correct here. So here it's supposed to be divided by divided by B minus A, but then you solve the maximization problem, you can take it out anyway because it's just multiplied by constant. And answer will be the same. Have you got it?
a second. Yes, I understand that we don't actually care about multiplying constants in the
Yes.
maximization problem, but still, I have a question. So to get n, what should we actually do? Like in the general form, we are dividing by total mass of whom?
So of everyone, right? So if we are talking about the fraction, okay, let me write it here. So then you have the distribution of agents and you have the theta hat, right? Then you have A divided by B. Oh, sorry, the interval from A to B. Your PDF function is theta divided by B minus A. It's if you have the uniform distribution from A to B. It's your PDF function.
Yeah.
So to calculate the amount who joined the platform 2, then you need to take the integral. Yes, so that's platform 2. You need to take the integral from A to theta from your. No, actually, the PDF is just not theta divided by. It's just 1 divided by beta over 2. So then your total mass is B minus A dt2. So then you have theta hat minus A over B minus A. What you should generally do is to take the integral from lower border to the indifferent guy and then multiply by PDF. So for green one, it will be from theta hat to B, 1 over B minus A. And this one, B minus theta hat, B minus A, right? Well.
Okay. But
is it clear?
Yes, it is now. But still, what of those expressions is total mass? It's the whole integral. No.
So the total mass is the integral from A to B, right? And PDF. And this is equal to 1. Right? Because it's B minus A divided by B minus A. Yeah, normally we assume
Yeah,
that we
okay.
have total mass of agents equal to 1.
So to determine the total mass, we just take the integral from the borders and by the PDF, right?
Yes, but that's like simple statistics.
Yes, okay.
And so the total mass, we always assume it equal to 1 because it's just the mapping. So it doesn't matter if it's 1 or 2, the problem wouldn't change. Yeah, if it will change if you have the different total mass of sellers and buyers. That's true. But if you scale the problem simultaneously for both sides, that's not play any role. So then let's come back to utility maximization problem. So they need to plug M2 into theta hat. So then let's do it. So now theta hat was equal to B is it B plus A, right? Minus 4M2 minus M1 over B minus A. And now they need to plug in our expression for M2, which is this one. Right. So then we have B plus A minus 4 times B, is it B minus A over 8, and then plus M1 over 2 minus M1, and then over B minus A.
Have we done first order conditions yet?
No, I just put, so that was the results of this profit maximization of the second problem, second platform, and then I put M2 into TJ, different one.
Yeah, okay.
Here. So just to simplify before. So that's B plus A minus, that's B over 2, right? And then we have plus two M1 over B minus A. Have you got the same?
Yes.
So now, and then let's write the profit of first platform. So that's 2M1, and then we have B minus theta hat. Theta hat is this one, and then plus A and minus 2. Right. And then, yeah, let me rewrite. So they need to maximize this with respect to M1. So then you have time to solve it. So then first done, I will start. So let me know when you receive the answer.
I think I've got the answer.
Mm-hmm.
So it's b plus 2a multiplied by b minus a, and all of this divided by 8.
Well,
8, not a.
okay. Not 8?
Yeah.
Okay. So let me check. Right. Then yeah. Then next question is, what is theta hat? So let's put it in. And what is was? Yeah, it was p over half minus a plus 2 and 1 over b minus a. So then we can plug it in. So that will be and then plus b minus a gone. Then it's over half, b over half, and then plus a. Right. So that's just b. Am I right?
Yep.
Yes.
So it seems like we don't even have to check the condition of existence of two platforms, because it's obvious that the second platform, well, not the second, well, one of them doesn't exist.
Yeah, the first one does
The
not
first one, yes.
exist. So, and I think on that strange result we can make a break. So that later you can check and resolve if I have some mistake. I don't have actually the solution from previous year here or some there. Yes. No, no, really. Oh, yes. Yeah, that's 8, right? So what's... Right. I did a mistake you haven't noticed. It's 8. It will be 1/4, right? So it's b/2 minus a plus b/4, and then plus a/2. So that's 3/4b minus 2/4a, right? Yes? Now what we need to check that theta is greater than a and lower than b. And then we have what's 3b minus 2a greater than 4a, and 3b minus 2a lower than 4b. That's 3b greater than 6a and minus b lower than 2a. Yeah, then probably minus b always greater than 2a since everything was positive. So b greater than 2a again. So did they got the same last time in the lecture, right? It was similar.
Yes, we got exactly the same.
So then what is the point is that the agent's supposed to be spread enough so that you have A and 2A and B somewhere to coexist to active platforms. So then let's have a break and we will have a look for next problem. Okay? How much you need? You need 15, 20 minutes? What would you prefer?
Maybe let's have 20 minutes, if you don't mind.
Yeah, I don't mind. So like in 05. So,
Okay, thanks.
so let's have 20 minutes of break and see you.